Hello, and welcome to our ME452 final presentation. My name is Jared Shattuck, and our group consisting of Christopher, Ben, Anna, and myself will be conducting a presentation about our quadcopter. A general description of our quadcopter is as shown. Some basic functions need to be taking quality video as well as photos, lightweight, easy to use, safe to fly, as well as able to handle multiple environments. We expect the production volume of our drone to be around 50,000 units per year.
Looking at both the primary and secondary consumers, for our primary group of consumers, it would typically be your average person or hobbyist that's looking at the drone for simple pleasure or perhaps photography. However, on the other hand, our secondary consumer would be individuals or teams looking for a robust and lightweight and very fast drone that's capable of performing stunts or other various maneuvers.
Now looking at the FAST diagram, we can see that the main function or objective of the quadcopter is to generate altitude. This is done by looking at the two things as shown, create airflow as well as direct airflow. Also, a very wide variety of other functions are also provided in this diagram. Now looking at the function component mapping matrix, which provides a link between the left-hand side of the various components that create the entire drone and links them to the current functions on the top row, which were provided directly from the FAST diagram. Here, the function differentiation table shows us the contrast between both the primary and secondary customer group and looks at which function that they would most likely want. Here, what's different between our primary and secondary consumer would be increased output. Derived directly from the function component mapping matrix as well as the function differential table, we end up here at the component commonality table. On the left-hand side, we have various platforms that will be the same for both customer groups, as well as on the right-hand side, we have the list of modules that will be different for each customer group.
For the assembly sequence analysis, sequence 1 was built from the ground, and sequence 2 was combined subassemblies. In comparing the two sequences, we determined that sequence 2 was the more optimal decision based on our criteria.
Now looking at the assembly sequence analysis, on the top-hand portion, we can see the assembly sequence before our redesign. On the bottom, we can see the new assembly sequence after the redesign that utilizes delayed differentiation. This allows us to delay the time in the manufacturing process that the new module is implemented, which overall helps. With the bill of materials and cost estimation, we have the wide variety of components as well as their quantity, material, assembly processes, and other various information in order to figure out the total cost of each drone. Looking at the quad chart for DfMA, we have the functional importance as well as the manufacturing and assembly cost. We looked at some of the components on the bill of materials and decided which ones had high functional importance and which one had high assembly cost, and decided to choose these for a potential candidate to redesign. Now looking at designing for manual assembly, we can see the drone takes around 500 seconds to fully complete. Looking at the total assembly time column, we can see various red boxes that indicate very high assembly time, which could offer clues of what to redesign. Now looking at the assembly efficiency of the total drone process, we have an efficiency of around 16%. Now looking at the first module part designed for manual assembly, we have the fan or propeller. As you can see, there was 3 redesigns chosen in order to help with assembly time, one of which being the cover, which was added to help facilitate orientation, the fillet, which helped with easy insertion, as well as snap fittings, which reduced the number of fasteners used to put the part onto the quadcopter itself. Now looking at the platform part we decided to redesign for manual assembly, this would be this one. The platform part we decided to redesign for manual assembly would be the spinner. As you can see, there was 3 redesign choices made in order to help reduce manual assembly time. One of them being the reduction of fasteners going from 4 to 2, which will help reduce assembly time while retaining functionality. Another thing too was a fillet inserted on the top of the shaft to help with insertion. The last thing was a snap fitting receiver in place of the previous threads to help receive the propeller snap fitting.
For the redesign for automated assembly, we focused on the top plate being the platform subassembly, with the subpart A being the bolts turning into studs, subpart B having no inner tray and basically having nubs and as a locating feature to help make the battery insertion easy, and then turning subpart C, the strap, into having it, instead of being a leather strap, having it have a strap fitting at the end following DFA 3/DFA 12. Before even deciding to redesign this top plate, we saw that there was so many different moving parts that should be something to focus on with all the different bolts and the miscellaneous tray under the battery holder, and this drove us to focus on combining parts as much as possible for ease of assembly. Our top plate was originally $1.16 per part, for the total coming out to 2.72 cents per part for the entire top plate, and that's how we ended up focusing on combining things for the next redesign. As you can see from our after redesign analysis chart, we ended up removing the indented battery tray, and that's where we ended up getting the nubs for ease of battery access. And then we combined the bolts into studs that ended up being combined with the top plate manufacturing, which brought the total manufacturing for the top plate to $2.10, but brought the total for the entire top plate redesign to $2.25 per part.
Here we have the process selection for the spinner. We took all of the different processes for stainless steel, and then we ran everything through looking at all the different criteria, and we ended up determining that this part can only really be made due to machining. So that's what we ended up going with. Here we have the process selection for the fan. We determined that the fan would be made out of nylon thermoplastic, and we then took all the different processes and went through the criteria. We determined that this part can only really be made through machining or injection molding. We determined that injection molding was ideal due to the fact that it's less expensive for the product volume that we are going for.
Based on the process selection and the design for manual assembly of the spinner component, we decreased the cost of the part by around 40 cents. This is primarily due to the simplification of its geometry. We were able to run the spinner component through Hubs' quoting system because it's a machinable component. After receiving quotes for the initial design and the redesign, Hubs was also able to decrease the cost of the redesigned part by around 40 cents. Hubs also had a significantly lower quote cost than our analytical methods. Based on the process selection and the design for automated assembly on the fan component, the price per component actually increased by around 10 cents. This is primarily due to the increased amount of mass and complexity on the injection molded part. During the original stage of the redesign, we used DfM Pro to analyze the original components to see if there was any significant features that could be altered. However, because we were adding large new features to the components, i.e. a snap fitting, we decided not to use the DfM Pro analysis in our final result.
For the product service systems, we have a few suggested ideas. One being data compiling, the other being an app for easy GPS and air updates, as well as a social app to meet up with other fellow enthusiasts. This brings many benefits, such as reducing waste, which helps the environment, as well as improving overall customer experience.
Thank you so much for your time, and have a great rest of your weekend.